Before I proceed, just a recap of what we did on the first day, that if we want to convert mole, we can convert mole into particles, volume, and mass. Volume is specifically for gases only. If we convert mole into the particles, particles means molecules, atoms, ions, whatever. Then we need to multiply by Na, and reverse will be the case that you need to divide the number of particles by Na. Na is Avogadro number 6.022 into 10 power 23. If you want to convert mole into volume of a gas, specifically at STP, standard temperature and pressure, which is 0 degrees Celsius and 1 atmospheric pressure, only applicable for gases, then you will multiply moles by 22.4 because 1 mole is equal to 22.4 liters at STP of any gas, irrespective of gas. So in these two arms of this diagram, for example, the particles and volume, we don't bother about what element we are talking about, what molecule we are talking about. So it is irrespective of which gas, which solid, which liquid, which compound, which element we are talking about. Number of particles will always be Na times moles, and volume of the gas will always be 22.4 times the number of moles. Opposite, obviously, you need to divide the volume by 22.4. The tricky part is in this conversion, mole to mass. But here again, if you know the molar mass or atomic mass, okay, molecular mass or atomic mass, you will multiply mole by that. So if you want to convert mole to mass in grams, you need to multiply that by molar mass or atomic mass, whatever you call it. Okay. Here we have called it molar mass because the answer we will get in grams. And as per definition, molar mass is atomic mass or molecular mass represented in grams, not represented in units, represented in grams. So that's why here it is written as molar mass, not atomic mass or molecular mass. Because if we write it as molecular mass or atomic mass, you will not get the answer in grams, rather you will get the answer in atomic mass units. That's why. Opposite will be you divide the mass by molar mass. If you have understood this one, then we proceed to next question for practice. The cost of table salt, and have your notebook and pen, just grab if you don't already have quickly, because I will ask you to answer the questions today. The question is cost of table salt is rupees 12 per kilometer per kg. Calculate cost per mole. Obviously, it is just unitary method. But first, what you need to calculate? You need to calculate cost. And in unitary method, whatever you need to calculate, you need to keep on right hand side. Cost you need to calculate. What is given? Mass is given. And what is the relationship? The relationship is that mass equal to molar mass, okay, that is something will be equal to 1 mole, and that's what is asked per mole. So if it is asked per mole, it means we are talking about molar mass in grams, because 1 mole, we have talked about it quite a few times, is actually equal to molar mass in grams. It means molar mass of NaCl will be 23 atomic mass of sodium plus 35.5 atomic mass of chlorine, that is 58.5 grams. So 1 mole is equal to 58.5 grams. So the question is simply now that if 1 kg costs 12 rupees, means 1000 grams costs rupees 12, then 58.5 grams will cost how much? Now this is the simple question, because 1 mole is equal to 58.5 grams. So you will say as 1000 grams NaCl costs rupees 12 and 58.5 gram NaCl costs 1000, sorry, 12 divided by 1000. into 58.5. So 58.5, if you roughly consider 60, right? 60 into 12, 720 divided by 1000. So the answer should be around something 7 to something. And if you see,
Yes,
that's
sir. Sir, I have taken 58.5 only and it has come 0.702.
right. Then it will be exactly 70, right? So it means
Yes, yes.
our calculations are correct because I had taken 60 here. So that's why answer was 72. If it is 58.5, the answer will be 70 paisa. Obviously, here you will get in rupees, you will have to convert that into paisa if you want. Otherwise, you can just mention rupees 0.70. That is also acceptable because the question itself talks about rupees 12. So answer in rupees is acceptable. Yes, your calculation was correct. I hope everyone is clear about it. Don't
Yes,
think that,
sir.
Yes, sir.
right, good.
Sir, can
Don't
I
think,
clear doubts for the assignment which you had given, sir?
yes, you can. I will give you around 10-15 minutes after the class. Okay.
Okay, okay, sir.
Towards the end of the class, I'll give you 10-15 minutes for that.
Okay, sir.
And one more thing, if you think that you will see the video afterwards and you will clear the doubts, that time never comes. Out of 10, 8 times you will not do that. Only for 2 times you might go through the video to look for what doubt you had. Okay, otherwise you won't do that. To get your doubts cleared during the class only. And as I said, these are basics. Obviously, we will be using these basics. You will face problem if these points are not clear. Next question. Calculate the number of molecules present in 1 decimeter cube of hydrogen at STP. This question I have just put here just to consider that
Sir, I was
whether you
having this doubt only, sir. I had to ask
Yes,
only this
sir.
question. Sir, the
ये
same
assignment 2 में था.
right.
question.
This question
Question 8.
basically asks you whether you know what 1 decimeter cube is. 1 decimeter cube is just 1 liter.
Yes,
Okay.
1
sir.
liter is equal to 1 decimeter cube. These are same thing. And it means, and what relationship you already know at STP, hydrogen is a gas, and relationship you already know. Okay, you know that 22.4 liters of hydrogen at STP will have 6.022 into 10 power 23 molecules because hydrogen exists as H2. It's a molecule. So here we will write molecule. Hence, 1 liter of H2 will have 6.022 into 10 power 23 divided by 22.4 molecules. That will be the answer. So it means it will be around 60.22 into 10 to the power 22. I have passed 110 from here to the this part 22.4. Now 22.6 threes will be 66. So obviously the answer will be 2.8 something or 2.9 something into 10 power 22. Let's see the answer.
2.69.
2.69. Okay. So when you solve it, you will get this answer. Is there any confusion now?
No.
No, sir.
Okay. And the trick that what you need to follow. Whichever question you were not able to do in assignment, just note down those questions. And I'll tell you towards the end of the class today that what 4 notebooks you need to maintain. Out of those 4, one is for your doubts. Okay, you will maintain all your doubts in one notebook, and certainly you will get maximum marks in chemistry if you can do that. Okay, because towards the end of the year, I mean to say towards the examination, final examination, you won't have that much time that you can revise everything. No. At that time, you should have only 10% of the whole syllabus, which you need to revise, which you need to fill the gaps with, which you don't know or you are weak in. For that, you will maintain 4 copies, and I'll talk about it later. Next question. How many electrons are present in 16 gram of CH4? Very easy question. Just you need to understand that here, you need to first calculate how many molecules, and one molecule has how many electrons, you need to multiply by that. So 16 gram actually CH4, the molar mass of CH4 is how much? 12 plus 4 into 1, that is 12 plus 4, 16. It means 16 grams of CH4 will be equal to 1 mole. So whatever is given here is 1 mole. And 1 mole will have 6.022 into 10 to the power 23 molecules. And one molecule has how many electrons? Carbon has 6 electrons. Hydrogen has 1 electron, but there are 4 hydrogens. That is 6 plus 4. 10 electrons are there in one molecule. It means number of electrons will be 10 times 6.022 into 10 power 23. These many 6.022 into 10 to the power 24 electrons will be there. So this question is just calculating the number of molecules, multiply that by the number of electrons in one molecule. I am just moving forward. If there is any problem, you need to let me know.
Sir,
Yes.
sir, how do we got the electrons?
Electrons we got because carbon atomic number is 6. And what is atomic number? Atomic number is equals to number of protons. And in neutral atom, the number of protons and number of electrons same. Okay? For example, if I talk about carbon, the atomic number is 6. It means, and this is not an ion, it means it will have 6 protons and 6 neutrons. Sorry, electrons. Hydrogen atomic number is 1. It means it has 1 proton and 1 electron. So CH4, carbon has 6 electrons, hydrogen has 1, but there are 4 hydrogens. So it means 6 plus 4, 10 electrons in one molecule. But there are how many molecules? There are 6.022 into 10 power 23 molecules. So you will multiply it with the number of molecules to get total number of electrons in all the molecules you have. Is that clear?
And sir, what is it 10 to the power 24?
10 to the power 24 is after simplification of this one. Okay, let me write it. You can understand it with unitary method if this is not right clear here. You will say one molecule of methane has 10 electrons. Is this a statement clear or not?
Yes, sir. Yes, sir.
Okay. Hence, 6.022 into 10 power 23 molecules. These many molecules you have because you have 1 mole. Why you have 1 mole? Because you have 16 grams. 16 grams of methane will be equal to 1 mole because molecular mass of methane is 16. It means 1 mole is equal to 16. Or you can say moles equals to given mass upon molar mass, that is 1. From there you got 1 mole. That is, you have 1 mole of methane. And in 1 mole of methane, you have how many molecules? You will have Avogadro number of molecules. So that's why these many molecules. Now you apply the relationship that in one molecule, there are 10 electrons. Hence, in all the molecules, I have 6.022 into 10 power 23. The number of electrons will be 10 into 6.022 into 10 power 23. These many. When you simplify this one will be 6.022 into 10 multiplied by 10 power 23, 10 power 24. These
Okay,
many.
sir.
Next question. Which one of the following will have the largest number of atoms? And there is a relationship you already know to calculate. Now, few students solve it. You don't need to solve in such questions because you know here it is visible. You have fixed quantity of mass. Mass is fixed. So it means you just need to have a relationship that is whether it is proportional or inversely proportional. From that, you will get the answer. Now, remember, number of atoms is proportional to number of moles. Why? Because number of atoms is equal to number of moles multiplied by Na. You remember this relationship? Number of particles, if you get mole here, particles
Yes,
here,
sir.
if you do this conversion, you need to multiply by Na. You know this. And Na is constant. So if Na is constant, it means if you remove this constant, number of atoms is proportional to number of moles. If number of atoms is proportional to number of moles, and what is the definition of number of moles? It is proportional to given mass upon molar mass. You know number of moles equals to given mass upon molar mass.
Sir,
Yes,
And
so
sir.
one
mass,
with least
In
molar
terms of
mass will
mass.
have most number of atoms.
excellent, excellent, excellent. Okay, good. And mass here is constant. If mass is again constant, it means number of atoms will be proportional to 1 by molar mass. It means in that case, now remember there is one catch here, obviously, because this one has molecule. This is not number of atoms, but obviously we will multiply by 2, we will get number of atoms. So now you will apply that the one which has least molar mass will have maximum number of atoms.
Sir,
Yes,
sir, how will we find molar mass in this case?
molar mass, it will be equal to atomic mass, right? Obviously in your examination that will be given, although I have not written here, it will be given. Gold is very heavy atom, very heavy atom. Okay? Sodium
Yes, sir.
around, lithium will have around 6, and chlorine will have around 71. Now if you consider the least atomic mass is of lithium, so denominator here minimum, the number of atoms will be maximum. So you will not be solving these type of questions. And why it took that much time? Because I was explaining, once you understand, you already know this relationship. Now going forward, you don't need to find this relationship. You already know this relationship. Okay? If molar mass is constant, for example, we are talking about the same atomic element or same molecule, then number of atoms will be proportional to mass. If mass is constant, then it will be inversely proportional to molar mass. So in all the books or internet, what you get, this question has been solved by calculation. And if you do calculation, obviously it is going to take a lot of time. It will take around 5 to 6 minutes at least. In such questions, objective type questions, you don't need to do calculations. Just get the relationship and the answer. So in this case, the answer will be 1 gram of lithium will have largest number of atoms. Any confusion, let me know.
No, sir.
Good. Next, calculate the number of grams of oxygen in 0.10 mole of Na2CO3 dot 10H2O. Now remember, in such cases, you will just find the relationship between one molecule and how many oxygen atoms are there. This is just one molecule of sodium carbonate decahydrate, because there are 10 H2O. You will find how many oxygen atoms are there. Here you have 3 oxygen atoms, and here you have 10
So
oxygen.
13.
Yes, good. Because this is 10 H2O, not 1 H2O. 10 H2O will have 10 oxygen atoms, means you will have total 13 atoms. It means 1 mole, first I am writing molecule, 1 molecule is equal to 13 atoms of oxygen. It means 1 mole is equal to 13 moles of oxygen. Remember, this is in molecules, so obviously these moles will be in molecule because this is a molecule. So there will be molecules in this case, but here these will be atoms only. In this mole, there will be atom because here we are talking about atoms only. It means 0.10 mole, this is given, will be equal to 13 into 0.10 mole. I'm just applying unitary method, nothing else. If 1 mole contains 13 moles of oxygen atoms, 0.10 mole will contain 13 into 0.10 mole. That is 1.3 mole of oxygen atoms. Now you have been asked calculate the number of grams, means it is mass. It is not written number of gram atoms. If it would have been written as number of gram atoms, then tell me in the chat window, don't say on the mic, then what was asked to calculate? If it were good. Yash, Vedi, Amir, correct.
Sir,
Kavish.
please repeat the question.
The question is instead of number of grams, if it would be number of gram atoms, then what you need to calculate? Number of gram atoms. Yes, Amar, Yash, Vedi, Kartikeya is correct. Yeah, Tanishi, Pratham, Arjun. Good, very good. Now, yes, yeah, correct, good. So it means in that case, we would have to calculate the number of moles because gram atoms means number of moles of atoms. But here we need to actually calculate grams and you know the relationship. 1 mole of oxygen atom is equal to 16 grams because atomic mass of oxygen is 16. So 1 mole of oxygen atom will be atomic mass in grams. Hence, 1.3 moles will be equal to 16 into 1.3. 16 ones are 16 plus 4.8, 20.8. So what I am saying, you have to calculate number of grams. And number of grams, and if you have understood the graph we talked about, moles are equal to atomic mass in grams. Do you remember that branch?
Yes, sir.
Good.
Yes, sir.
So if you remember that, so 0.1 mole of Na2CO3 dot 10H2O will be its molar mass in grams. But if you follow this approach, you will have to calculate the molar mass of whole Na2CO3 dot 10H2O. To avoid that, what I did, I found in 0.1 mole of Na2CO3 dot 10H2O, how many moles are there of oxygen atoms? Because I am talking about number of gram atoms of oxygen only of oxygen. So if I can get the number of moles of oxygen, I will apply the method that 1 mole of oxygen atom will be equal to its atomic mass in grams. So whatever moles I get, those will be equal to how many grams? I will apply the unitary method. So that's what I am doing. I'm first calculating how many oxygen atoms are there. Oxygen atoms in total one molecule of this one are 3 plus 10. These are 10 actually. 13 atoms. So one molecule of Na2CO3 dot 10H2O has 13 atoms of oxygen. Is that clear or not, everyone?
Yes.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
If that is clear, then we have to calculate the grams of oxygen, means we need to convert the number of moles of oxygen to grams. That is the easiest way. We know that. To get the grams of oxygen at how we can convert? We can get it from moles of oxygen. And how we can get the moles of oxygen? We can get from moles of Na2CO3.10H2O if we get that relationship. So in 1 mole of Na2CO3.10H2O, we have 13 moles of oxygen atoms. Because there is direct relationship, whether you consider one molecule, 13 atoms, or you consider 1 into 6.022 into 10 power 23 molecules equals to 13 into 6.022 into 10 power 23 atoms. So don't go into those details, you will get confused. Keep it easy. Whatever is relationship in the particles, the same relationship is in moles. Moles are directly proportional to the number because this is just a constant you need to multiply by. And that constant is Avogadro number. Okay. You just need to get it clear that these moles are molecules actually because Na2CO3.10H2 exists as molecule. But 13 are atoms. So here whatever mole will be there, those are in terms of atoms. That is simple thing. And you don't bother about it because the mole ratio will be same thing. 1 mole of Na2CO3 will be equal to 13 moles of oxygen atoms. Okay. So 0.10 mole of this one will be 0.10 into 13, that is 1.3 moles of oxygen atoms. And then you know the relationship. 1 mole of oxygen atom is equal to 16 grams. 1 mole is equal to atomic mass represented in grams. So 1.3 mole will be equal to 1.3 into 16 grams, that is 20.8 grams. This is just the unitary method. You need to understand how it is applied here. Now tell me who is not clear about it. Which step is not clear? Which step is not clear? Go through all the steps and tell me which step is not clear or where the confusion is. Don't think that others will laugh because otherwise if you don't get marks in examination, then many person will laugh at you. Even those who are not in this class. So it is better that you get your doubts cleared right now.
Sir, I have a sir doubt not in this method, sir. But if we had done the way, sir, like we would have done, sir, then we had to calculate the molecular mass of sodium carbonate. Sir, then after that we would have multiplied it by the number of atoms of oxygen. This, sir, then also the answer would have been the same, no?
Yeah, answer will be same. You're right, but that will involve more calculation.
Lengthier process, sir.
Yes, lengthier process. Otherwise, that
Okay.
is also the correct approach. There you will be dealing in terms of molecules and atoms. Here we are dealing in terms of moles. That's the difference. Anyone
Sir,
else?
sir,
Yes.
I didn't understand the part where 1 mole of Na2CO3.10H2O has 13 moles of oxygen atom, sir. I didn't understand that part.
Yes. Understand it like that. I am taking something simpler thing. Okay. H2O molecules, oxygen atom. Okay. One molecule of H2O has one oxygen atom, right?
Yes,
It
sir.
means 6.022 into 10 power 23 molecules will be equal to 1 mole in this case or not?
Yes.
And if one molecule is equal to one atom, 6.022 into 10 power 23 molecules will be 6.022 into 10 power 23 oxygen atoms.
All atoms.
And here 6.022 into 10 power 23 atoms will be equal to what?
All
One
atoms.
mole. One mole.
Okay.
The one mole of oxygen atoms will have 6.022 into 10 power 23 atoms. 1 mole of oxygen dioxygen will have 6.022 into 10 power 23 molecules, because this one is a molecule, but here we are talking about atom. So these many atoms will be equal to 1 mole. Here it is molecule, these many molecules will be equal to 1 mole. It means whatever was the ratio of molecule versus atom, that is the ratio of moles also. Go through these steps, understand, and if there is still any problem, let me know.
Sir,
Yes.
sir, if we had to convert that O2 molecules into atoms, sir, we would
Then you would
multiply.
have done double, right?
Yes,
In
sir,
that
we would
case, it would
multiply
have.
that. Yes, sir.
Yes, yes,
Okay,
right.
sir.
But here, because we have already considered only the atoms, 13 atoms, not O2, so it means that will be the number of moles of the atoms, and that's what we need to consider because question asks about the atoms. Is that clear?
Yes, sir.
Yes, sir.
So the answer will be 20.8 grams. Next question. The mass of 94.5 milliliter of a gas at STP is found to be 0.2231 grams. Calculate its molecular mass. Now, again, if you remember that chart I explained, you will be able to answer this question very easily because this is just a relationship between the volume and mass. And what is the relationship? The relationship is here you have volume and here you have mass. The relationship is that 22.4 liter is 1 mole and 1 mole is equal to molecular mass in grams. So it means these two figures should be equal. 1 mole is equal to 22.4 liter at STP of a gas and 1 mole is equal to molecular mass also if represented in gram. Apply this. 22.4 liters or 22,400 milliliters are equal to molar mass in grams. Okay, so you need to calculate how much mass will be there in 22.400 milliliter. That will be equal to molar mass. Tell me whether this point is clear or not.
Sir, it's clear.
Yes.
Because molecular mass is nothing but the molar mass represented in U. Other way around, molar mass is equal to molecular mass represented in grams. Molecular mass is molar mass represented in U. These are same thing. For example, if I say oxygen atom molar mass will be 16. Molecular mass will also be 16, but molar mass will be 16 grams. Molecular mass will be 16 U. That's the only difference. But this figure will be same. So if I have to calculate the molecular mass, it means I can calculate the molar mass. Same will be the molecular mass. And what is the relationship given to me? The relationship is 94.5 milliliter is equal to 0.2231 gram. Hence, 1 milliliter will be equal to 0.2231 divided by 94.5 grams. Hence, 22,400 milliliters will be equal to these many grams. and 22,400 milliliter is equal to 1 mole. So whatever grams are there, those will be equal to molecular mass. That will be the answer. So when you simplify this one, 22 into 22 will be 484. 484 divided by slightly less than 100. So it should be around 5. First digit should be close to 5, and let's see the answer. Yes, correct.
Sir, can you please explain the second step, sir? Sir, in which you divided so by
This one?
94.1. Yes, sir.
This is basically unitary method. Unitary method says, and this is something you might have done in your 8th, 9th, 10th, that if 12 oranges cost rupees
Sir,
40.
I understood this part, but sir, what were we supposed to calculate in second step, sir? That I couldn't understand, sir. What we are getting
That's
from the
what I'm
system.
explaining. That's what I'm explaining. Okay? If
Oh,
12
okay.
oranges cost rupees 40, then calculate cost of 3 oranges.
So
So
40
that's
by
what
12
we
into
do.
3.
Yes. So what we do, we say that as 12 oranges cost rupees 40, hence one will cost. That's why it is called unitary method, because we involve unit here. And this step says that one will cost always 40 divided by 12. So this goes into the denominator, this goes into the numerator. So in first step, it is division, 40 divided by 12. And then in last step, third step, you calculate in how many. Hence in 3 will cost whatever you get here, 40 by 12, and then you multiply by this number 3. From here to here, it is multiplication. So this is what I am following the steps of unitary method here. Same thing I am doing in calculation there, that if 94.5 grams, sorry, milliliter weighs 0.2231 grams, then 1 milliliter will weigh 0.2231 divided by 94.5. This goes into the denominator. And hence, whatever you have to calculate in, you have to calculate into 22,400 milliliter. Then you will multiply this one, 0.2231 divided by 94.5 by this 22,400. Here it will be division, and here it will be multiplication. So this is the steps. These are the steps of unitary method, nothing else.
Sir,
No
so
fancy.
this gives us the mass for 1 mole, sir.
No, this gives us, yes, obviously, because this is equal to 1 mole. You're right.
Yes, sir.
This is equal to 1 mole. So this gives us mass of 1 mole. That's why we
Yes.
will call it molar mass, because
Yes,
question
sir.
asks about the molecular mass that will actually be equal to molar mass represented in AMU,
Grams. Yes, sir.
molecular mass in AMU.
AMU, sir. Yes, sir. Okay, sir.
Is that clear? So you will get 52.9 U. If molar mass would have been asked, you will write the unit as grams. Molecular mass unit will be U. Anyone, any confusion? Slightly more effort will be required from 10th grade. So don't be in that comfort mode. Okay? And that's why if you do the assignments on daily basis, that will be sufficient. And that's why I will be keep pressing you to submit the assignments on time. Daily something will work, but if you try that you don't do something on 2 3 days and then on one day you do 30 questions, if 40 questions, it won't work. You won't be able to do it. Only 10 to 15 questions daily, simple questions plus complex questions later on, it will work. Calculate the actual volume of one molecule of water. Now, slightly tricky question. It is very easy one, but tricky. It says you need to calculate the volume of one molecule. And you know that 1 mole of water will have how much volume? Tell me in the chat window, I'm saying you know the volume of
Sir,
1 mole. No, not in the on the mic, because I know many of you will give me wrong answer. In the chat window only.
Sir, can you
sir,
repeat
can
the
you repeat
question?
the question?
Okay, my question is, what will be the volume of 1 mole of water? Uh, Tanishi Mitra, correct answer. Kavish, think again. Yes, Goyal, think again. Samad, think again. Kartike, think again. Arjun, think again. Subway, correct answer. Lemuel, uh, I'm talking about no. However, one digit you have included, that is correct. No, Samad. Might be that you tried to write correct, but for enough correct answer. Good. So that's why I asked it, because if you remember, that's why I gave you the question homework in first class, that this is the common mistake. And that's why I am forcing you again and again so that you don't make this mistake. This is not a gas, this is water. So there is no involvement of 22.4 at all. Okay. So you will say that 1 mole of water will be equal to 18 gram. Sorry. Yeah, 18 gram. And 18 gram will be 18 milliliters, because water's density is 1 gram per ml. One gram per ml means in 1 ml there is 1 gram. This means in 1 ml we have 1 gram of water. So 18 gram will be equal to 18 milliliter. So it means 1 mole will be equal to 18 milliliter. But again, you know that 18 gram is 1 mole. And it will have 6.022 into 10 to the power 23 molecules. Everyone pay attention. No one will sit lethargically. This is everything. That diagram only I am applying the concepts again and again, okay, in twisted ways. And once you do the practice, you will be able to do these calculations in your mind. I am telling you again. After 1 week, you will not require even to write these things. You will calculate these things in your mind. But one thing, just do these questions, practice. So 18 grams basically equal to 6.022 into 10 power 23 molecules. So what will be the volume of one molecule? 18 gram is 18 milliliter. So from here you got the relationship that 6.022 into 10 power 23 molecules equal to 1 mole, and 1 mole has 18 milliliter. So it means these many molecules occupy 18 milliliter space. So what will be the volume of one molecule? That will be 18 milliliter divided by 6.022 into 10 power 23. Now 18 by 6 would have been 3, but this is greater than 6, so it will be slightly less than 3. It will be 2.9 something into, when 10 power 23 goes to the numerator, 10 to the power minus 23 milliliter. That is the answer. Kshitij has given me the correct answer already. Good. Now, in simple terms, after explaining this much, in simple
सर
terms,
2.99 की जगह अगर 3 लिख दे तो भी सही होगा ना?
normally it is accepted, okay, but it depends on your teacher. Sometimes your teachers are so strict that they say, no, it should have been 2.99. But Normally I have seen at least in board examination, 12th board examination, that is acceptable. So in board examination, examiners are advised that there is error margin, and within that error margin, you will get full marks. So in simple terms now, understand this question. What is the volume of one molecule of water? And whenever it comes about molecule, think 6.022 into 10 power 23 molecules, because that is 1 mole. So if you can compare 1 mole with 1 mole, you might say, why? I am writing the same thing. But 1 mole in numbers and 1 mole in volume. 1 mole in numbers will be 6.022 into 10 power 23. 1 mole in volume will be 1 mole will be 18 gram. 18 gram equals to 18 milliliter. So that's simple it is. So it means these two are equal. If these two are equal, now you can apply unitary method. 6.022 into 10 power 23 molecules have volume 18 milliliters. So one molecule will have 18 divided by 6.022 into 10 power 23. Get answer. Don't think that you will do it later on. If anything is not clear, just get clarified. Most of these questions, again, you will have in the assignment. And I will not enable the recording of this class until you submit the assignment, because otherwise you might just see the video again and write the answers. Next. Calculate the radius of a water molecule assuming to be spherical. Density is given. Density you should already know. Even if it is not given, you should already know water's density is 1 gram per ml. 1 liter is equal to 1 kilogram, or 1 milliliter is equal to 1 gram. Now understand. Here again, radius given, you can calculate the volume. Calculate the radius of a water molecule assuming to be spherical. Density is here, and volume you have already calculated. Volume of one molecule you have calculated 2.99 into 10 power minus 23. So from there, obviously, you will first calculate the volume. Volume of one molecule of water is equal to 2.99 into 10 power minus 23 milliliters. It means this volume is 4 by 3 pi r cube. It is given, it consider it pure spherical, and you know the volume of a sphere is 4 by 3 pi r cube is equal to 2.99 into 10 to the power minus 23. Now there is a catch. The catch is here you have this in milliliter, and R you will get in centimeter, okay, or meter. R cannot be in milliliters, and that's where the students make mistakes. Okay, so this is something you need to convert it into centimeter. Now remember how I am saying this milliliter is centimeter cube. Okay, you know that 1 milliliter is equal to 1 cc is equal to 1 centimeter cube. If you don't know, just remember 1 milliliter is 1 centimeter cube, or also written as 1 cc.
Sir, CC represents?
Centimeter cube or cubic centimeter.
Okay, sir.
These are same thing. So the point here is when you calculate the radius, you have to have all the units same. So don't write milliliter, write it centimeter cube, because here the radius has to be in SI units. SI units of length is meter, and you can obviously convert it to centimeter. So with that, when you do all the calculations, then you will get the answer as 1.925 angstrom. Now here it is written in angstrom because the answer you will get, it will be so less in quantity that you will have to convert it in angstrom, and the units are 1 angstrom is equal to 10 to the power minus 10 meter. Okay. I'll solve it so that you can understand. Okay.
Yes.
Now because we know the conversion, direct conversion between meter and angstrom, 1 angstrom equals to 10 to the power minus 10 meter. Convert this centimeter cube into meter cube so that our calculation is easier. So write it like 4 by 3 into 22 by 7, or you can use 3.14 if you want, okay, into r cube equals to 2.99 into 10 to the power minus 23 into centimeter cube is actually 1 centimeter into 1 centimeter into 1 centimeter. That is centimeter cube. If you convert it into meter cube, it will be 10 to the power minus 2 meter into 10 to the power minus 2 meter into 10 to the power minus 2 meter. That is 10 to the power minus 6 meter cube. Just let me know whether this conversion you could understand or not. I am converting 1 centimeter cube to 1 meter cube.
Sir,
Yes,
sir, how do we get this 2.99 into 10 to the power minus 23 milliliter?
from here. Volume of one molecule we have calculated in previous question.
Okay, sir. Okay.
First, you will calculate volume of one molecule, and then you will say as volume, if radius is r, then volume of the molecule will be this much. You will equate both.
Sir, in general, when we solve questions, sir, and we have to calculate the volume, sir, in which unit should it generally be?
Well, in physics, normally you deal in macro molecules, macro objects. Macro objects means you can see. So there, these can be centimeter, meter. But in chemistry, atomic radii, these things are in picometers, nanometers. So you need to
Okay,
use the units in picometer, nanometer, angstrom, etc.
okay, sir.
Very small. Now, why I am using here first meter cube? Because I know the relationship. Once I do the calculation in meters, after that I'll convert it to angstrom, or you can represent it in nanometer or picometer. The answer will be correct. Here answer is given in angstrom. You can give answer in picometer or nanometer, and these units certainly we will be talking about in this chapter only later on. So it means 1 centimeter cube will be equal to 10 to the power minus 6 meter cube. So you need to multiply this centimeter cube to convert into meter cube by 10 to the power minus 6. So it means volume of one molecule will be equal to 4 by 3 pi r cube if radius is r. And in previous question, we calculated 2.99 into 10 power minus 23. So we substituted that one. Yes, it is equal to this much, but we converted it into meter cube. So we multiplied it by 10 to the power minus 6. Now we can simplify this one to get the value of r cube. Okay. So you can simplify and get the value of r cube something, and then you need to take cube root of that one. When you take cube root of that one, you will get answer is in meter cube, remember. Okay? Meter, sorry, in meter. These many meter. And then you will multiply that with 10 to the power 10 to get angstrom. Remember, I am multiplying by 10 power 10, not 10 power minus 10, because 1 angstrom is equal to 10 to the power minus 10 meter. 1 meter is equal to 10 to the power 10 angstrom. Angstrom is very small unit. So there will be a lot of angstroms in 1 meter. So there will be a lot of angstroms in 1 meter. So that's the way to remember that you don't make mistakes. I have seen students making mistakes here, just doing opposite. However, the common sense says that meter is much bigger unit than angstrom, so there will be a lot of angstroms in 1 meter. So it has to be 10 to the power 10, not 10 to the power minus 10 here. So multiply the result by 10 to the power 10, those many angstroms will be there. That will be the answer. I am leaving the calculations to you because you have to do these questions in next assignment. Once you solve, here you will get 1.925 into 10 to the power minus 10 meter. When you will multiply it by 10 to the power 10, you will say it is 1.925 angstrom.